visually, then all the probabilities are also visual. So if you got a shape up there, the probability should be the area. Sort of like that dartboard I put up here. If I just randomly throw things at a dartboard and I got the bullseye is this big, it's going to be very unlikely just to randomly hit it, right? So you can actually test somebody to see how good they are. If they get a very unexpected number of things in the bullseye, they must be pretty good. That would be evidence that they're good. So the nuts and bolts of this, how many of you guys have your books with you? Hopefully. I'll put something up here too. I think, good. Decent number, you guys. I see lots of books. Good. But just to kind of go along with this, we'll do a couple real quick ones. So on the very, very, very back flap of your book, it's also in the insert, if you still have the insert. Let's do a couple quick problems here.
Online homework, is there a table like this for the reference, or are they going to ask me these particular questions?
Have I put chapter 6 homework up there yet?
Yeah.
Okay, good. Thank God. I thought I did. Tell you honestly, I think they have I think they have a reference you can hit, and then it's. I think last time I put it from the computer, I went to the website, and you can actually just pull it up there. But I think inside the homework, it should have something you can click and see the table. Yeah. Poor little dude. Oh yeah, it's this guy. Yeah. So, I know I have nothing up there yet. If I want this, probably Z is less than 1.18. So if you missed class last time, remarkably quickly, this chart is empirical rule on steroids. Empirical rule I can only do within 1, within 2, within 3.
And it's always, the mean is always 0, and standard deviations always 1.
When they're Z-scores. So we'll do a problem where I have to convert to Z-scores, and you'll see how that works. Because the Z-score, again, tells you what?
Distance from the mean.
Distance from the mean measured in standard deviation. So of course the mean is always going to be 0, because it's 0 away from itself, right? 1.18 is somewhere up there. And I want probably it's less than that, so I want this. So if you were here last time, you saw that this chart is set up to do exactly that. The chart tells me the area below something. So when I look up a Z-score of 1.18,
0.8810.
whoa, 1.18, 0.8810. So this top piece is the second decimal point in your Z-score. So it's a nice quick way they can do this without making it this huge thing you have to roll out. 0.8810. And that's my answer. Now, if I had, if I said the probability Z is greater than 1.18, how would I get that?
Minus subtract.
Yeah, now I want above 1.18. I know this is 0.8810 from before. This must be the rest of it. Cool. So I'm hoping to God on one level, this should be not boring, but you should kind of see how this works. I've been building up to this point. If you know one probability, the opposite is 1 minus that. So if I know that side, the opposite would be 1 minus that. And the only other thing that could really happen, the only other general situation that could happen with this kind of problem is the probability between two things. So if I want the probability that Z is between 0.71 and 1.98. If you draw the picture, it tells you exactly what to do. So here I've got 0.71, and 1.98, and I want this area between.
Find the difference.
Whenever I look a number up in the chart, it only tells me one thing. It tells me the area below that, period. So when I look up 0.71, I get that area. And what's that? 0.71 looks to be 0.7611. Is that cool? And when I look up 1.98, what do I get?
.9761.
9761. Cool. So if I want the area between those two, it only makes sense. This goes too far. If I chop this much off, it'll just be this much. So that's why I subtract. Right? So if I want the area between two things, I just subtract the areas. Don't subtract z-scores. Like I said last time, that would just move you somewhere else. So I take 0.9761 minus 0.7611. I think that's easy. 1.215. Oh. Now, real quick, right now, these, especially if I only talk about z-scores, these are just freaking numbers. And I always try desperately to get you to realize this is just getting the nuts and bolts of how this works. So right now, this number is not very interesting. It's just saying there's 21.5% of a normal distribution is between those two z-scores, right? So a more interesting problem would be, let's see. Let's try this one out. So from this one, we found out that the mean is 30, right? And the standard deviation was 2.738. Now there is one little thing that I'm going to talk about later. Right now we're just going to kind of ignore it. But I'm going to come back to this kind of problem because could you get 11.3 peapods that were green?
No.
No, either it's green or it ain't, right? You don't say, well, it's kind of greenish and then no, it's green or it's not, right? So it's discrete. So for the moment, I just want to get some numbers to work with, some real life numbers here. So I want to know the probability that it's between, let's say, 24.5 and 35.5. That should be close to what? Who could tell me what that should be close to? No, I want the probability that it's between these two, right? And where do these two numbers come from? What are they supposed to be containing? Where are those two numbers from? Two standard deviations away from the mean, right? Why did we go two standard deviations away from the mean? Why does that have to deal with unusual or not?
Beyond the minimum or beyond the maximum is unusual.
Why? How much is beyond those if it's normal?
Or to calculate it.
Say again, 5%. So there should be how much inside then? Okay, that's what I'm trying to get to. So if I do this, I should get close to 95% between those two. There's a couple reasons I won't get exactly that. These are rounded, and this isn't really continuous. But I just want to, let's just see. I should get close to 95% here, right? So let me put this in a question here. What's the probability that I see between 24.5 and 35.5 peapods, right, that are green? So draw the picture out. We don't need this anymore. We don't need this anymore. Okay. What's the picture going to look like? Like that, Jeff? Yeah, but more specific, what's going to be right in the middle? Which is 30. Beautiful. Not 0 right now because we're dealing with raw scores right now. When I convert them to z-scores, I'll put a 0 down there, right? So the mean is right in the middle, 30. And then I put on there my 24.5 and my 35.5. So I want this area here. So this was not too bad here because they were already z-scores. So you just had to look them up in the chart. So of course, what do I have to do over there? Make them z-scores. Obviously, I'm never going to find 24.5 on the chart because it only goes up to 3.5. Once you get past that, it's really freaking unusual to be that far out. I've got to convert these to z-scores. So how do I convert 24.5 to a z-score? What would it look like for the formula?
4 minus
5 minus over 2.7 minus 30 on top.
Thank you. Cool. Right? Our number that we're interested in minus the mean divided by the standard deviation. So somebody help me out. What would that be there? Neat. Right.
I got negative 2.008 seconds.
I think you just put in, yeah, negative, yeah, you got negative 2.01. And of course, this one would be what? Not amazing. Not surprisingly, that's
2.01.
positive 2.01. Yeah. Now, on one level, we should not be surprised about this at all, because where did we get these numbers from? We added and subtracted 2 standard deviations. And what's the z-score tell me? It's really just re-verifying that, yeah, you got about 2 up and 2 down, right? So of course, now when I look these up with the chart, whoop, you already got the picture. So over here I can go back, I'll put this is 0. This z-score was 2.01, and this z-score was negative 2.01. So you can just put in parentheses your z-scores. So what do you get when you look up 2.01? 0.9778. So 2.01, cool. And then negative 2.01. .0222. Okay, cool. And when you subtract those, sure enough, you get 0.9556, which is pretty damn close enough to 95% for me, right? So when you subtract those, you get 0.9556. So that's section 6.2. They only have z-scores in 6.2. And 6.3, they do one more step. They start off with x's, so you got to make them z-scores first, right? Okay, cool. So let's do this. Sounds like most of you guys haven't done it yet, which is beautiful, which is actually perfect. On that handout I gave you last time, number 4. Go ahead and try to do that. If you need a handout, if you don't have it with you, there's some up here. And there's some calculators up here too. But, yeah, Charlie Chaplin, you can't beat that. I don't mind looking like Charlie Chaplin. So definitely feel free to work together.